Hey YouTube, we're here with some bench testing. I redid this a little bit. I've got it mounted a little firmer to the table, and I've got this little crash guard, which will hopefully, in case the props decide to try to fold back, it'll spare the prop. I don't really think it's going to be necessary, I hope. But also we've got the ESC programming card here. Just noticed there was a nasty edge on there. So basically, this is a little bit different system than I'm used to, and I've got my 2200 milliamp 60C 3S, and we got a little voltage alarm which shows the individual cell voltages for our testing. Lemon RX 7-channel with stabilization, dual diversity, N-pin DSMX receiver, and we got a little load tester. So I want to show you how this programming card works. Now real quick, I wanted to show you this too before we get started. This is the programming manuals for the ESC receiver, or the electronic speed control, but it says W or YGE. I'm not sure why that says YGE. And then we've got this is like the book. I don't know what the difference is. There's like quick reference and then another thing. So this is level 2. All other functions like governor mode can be accessed through level 2 by pushing briefly the 2 left buttons simultaneously. The level switching occurs on release of the buttons. Okay. Oh, for confirmation, the menu LED is blinking now. Okay, so I wanted to show you kind of how to do all this. So the battery's unplugged now. Got the receiver turned on, throttle's down, and throttle cut's on. Let's just verify throttle cut. It is on. You see in this menu, throttle doesn't move, throttle does move, throttle doesn't move. Okay, so we're safe. Of course, normally you would do this without the props on, but I'm going to be doing load testing in about 30 seconds. And we have everything securely mounted. We got the 40 amp brushless ESC with 5.5 volt at 5 amp BEC. And this is what they mean by level 2, level 1. Okay, so we'll go ahead and show you how this is hooked up. It says brown here, so you know which one the ground wire goes to, and that comes from the ESC. And then there's a brown wire, and it comes with this jumper, and then you plug that into your throttle output on the receiver, or whatever. I don't think it matters which one. Plug it in. As this initiates, goes through flashy lights. These are the left buttons, so you press both of those and it'll go to the second page. So let's look at all the settings. So we're in timing currently. It's at 18 degrees, which is the middle. That was the default, so we're just going to leave that. We'll press enter. So it's set that. Now we'll press this little button and it goes to brake. It says off. So currently it's off. It gives us an audible feedback through the motor. I'm going to change that to acro hard, smooth, middle, and hard. Okay? So I'm actually going to go to smooth. Okay? Now we've set that. Now I'm curious, will this work now? Throttle cuts off. Let's just see. Nope, it doesn't. Okay, good. That's actually good to know. Throttle cuts on, timer's cleared. Okay, so now we can go cut off type, ACU type. So there's 2 on here. So you see how there's 2 lights that are lit up. Cutoff voltage is set to 2.3. And 2.7. Oh, for LiPo. Okay. And it slows down. So at 2.7 volts per cell, we're going to go to slow down. And at, I don't know, that's pretty high up, or that's pretty low down. That's going to kill the battery. But you know what? At that point, we're in duress anyway, so it doesn't really matter. So the cutoff voltage is going to be at 2.7, 3.4. Why is there two? I'm not sure. Oh, one's for... Well, I guess it depends on which battery type. So either way, I'm okay with. Okay, so we wrote that. I'm actually just going to try this real quick and see how it changes. Okay, so it goes to off, meaning there is no cutoff. Then it goes to slow down. Then it goes to cutoff. Then it goes to this type of battery, this type of battery, and that type of battery. So we'll enter that type, LiPo. Not really sure exactly how to set the second setting, so let's go back to it. That's very strange. Interesting. So the cutoff type is, I want it to be on slowdown. And then for, we want it to be LiPo. Okay, now we can switch down to the next one. Cutoff voltage. I want it to be cutoff voltage of, I want it to be a little more than that. No. I probably want to do it at 3.2 because my alarm will go off at 3.3 per cell. So we'll write that. And then we'll just go to the next one. The cells, in this case, I'm not really sure exactly what that's supposed to do. Looks like 4 through 15. I don't know what the heck to do with that, so I'm just gonna keep going. Special functions: beep, short, stop, full speed, auto timing. I'm gonna go to auto timing, and I'm gonna write that. Okay, so now if I press this, it goes back to the top. So now what I'm going to do is I'm going to press both of these. When I let go, it flashes to tell us we're on page 2. Okay? Okay, now it says active free WGov mode. It's off and off. Whatever. I don't know what the heck it does, so I'm not going to mess with it. Then governor mode P gain. Don't really care. Governor mode I gain, startup speed, plain middle. That's good enough. So the startup speed is the speed by which this starts to rotate when you give it throttle. Oh man, I'm not sure if I want to go middle or slow, because typically with a folding prop you want to slowly engage it so it's easier on the root of the prop. So, I guess for now I'll probably go ahead and put it to plain slow. And then pulse width modulation frequency, don't know. Startup power is auto 1 through 32%. Okay, not sure what that means either, so we'll just go back. Okay, now we're back to, whoops. We're back to regular page 1 mode. So now we should be able to just, when we're done, let's see if the instructions tell us what to do when we're done. After programming, please disconnect the flight battery and then reconnect the ESC plug into the receiver. Okay. Alright, so unplug the power to the pack. Disconnect this wire. This wire will more or less stay plugged in. And then this wire will come undone. We can lay this programming card aside. We'll go ahead and make sure this gets plugged in right. Negative is on the bottom. We're going into the throttle channel. Lemon RX, these decals don't always line up perfectly with the pins, so just be careful that you kind of count your way over if there's any ambiguity there. Alright, and I'm also going to lay this over here so it's out of the way. Actually, we might be producing a little wind, so I'm going to move this over here with the programming manuals. And with a more complex system like this, it's probably a good idea to keep those manuals handy. Incidentally, we never did actually weigh this for you on the video, but I did weigh it. And so I'm going to show you the results. Okay, so before, with the big ESC, the 60 amp Hobby King Plush, which is sitting out here, we had, it was pretty heavy, 76.75 grams. And then the Aerostar ESC, which is sitting here without the adapters, okay, these are from the smaller size to the bigger size, we were at 45.8, and I think we figured on about 3 grams of additional weight for the larger, but there is an XT60 on there. That was 45, so we'll call that 48.8. With the new YEP 30 amp, I used my derived weight gain of 9.15 grams for the XT60 and the 3 plugs for the ESC, as well as the heat shrink on all that. And so that brought us up to 52.9 grams from 43.75. So I added 9.15 grams to the original 30 amp, and that became 36 grams. So basically this one's about 53 grams now compared to what we had at, let's just call it 48 grams. So about a 5 gram difference or so. Definitely grams well spent in my opinion, but it is definitely extra weight. So without further ado, let's go ahead and try some testing here. Throttle cuts on. Just a quick once over on everything. Listening for the startup. Okay, everything's started up. It's making all sorts of singing songs at me. I'm not sure what for. Okay, throttle cuts off. We're just going to test it and see if it goes the right direction. Okay, so it moved. Throttle cuts back on, making sure it doesn't move. And honestly, I didn't pay attention. I couldn't tell what direction it was going, so we'll try that one more time. Going the wrong way. Throttle cuts on. Timer's cleared. We're going to switch 2 of these leads. Doesn't matter which ones. Just want to make sure we don't short anything out. Okay. So now it's plugged in. Should be going the right direction. Let's verify that. Okay, so it's going the right direction now. I do not want that to hit. I may have to take this guard off. This guard might not be doing what I want. Okay. Okay, throttle cuts on. We're just going to pull this guard out. It's not doing what I want. Let's just try shifting it a little bit first, because I still like the function of what it's going to be doing if it does what it's supposed to do right. Okay, throttle cuts off. You can see how slow it comes up. So when I give it throttle, it's definitely given. You guys can see where that prop is. Nice and powerful. There's your braking. And that's really smooth. And it's definitely braking. I can tell it's braking because it doesn't want to keep spinning when I flick it. Okay? And then I want to show you the inrush current is going to be lower now, actually, because we're going smooth. So jack the stick all the way up. All the way down. All the way up. All the way down. Which I didn't think about it, but that means that we're never really going to get the inrush current that we were getting before, which is about 25 amps. Motor's a little bit warm. I would say maybe 100 degrees. The ESC itself, cooler. Okay? Full throttle. All the way down. Full throttle. All the way down. Okay, so throttle cuts on. Check our voltages. 3.8. Okay, so we're still good there. So what I want to do now is I actually want to go ahead and unplug this power. We're going to plug the programming card back in, and I want to change the timing from slow to medium, which was, I think we did plain slow. So let's go to page 2 on that. So unplug the receiver. We'll plug the receiver into the programming card. Okay, then we'll go ahead and plug this back into the throttle channel, which is the second set of pins over. Then we'll go ahead and throttle cuts on. Everything's working there. Plug it in. Everything's started up. We got our lights flashing like crazy. We're going to press both these buttons. Upon letting go, it should start flashing. Starts flashing. And what we're looking for is, okay, so we're looking for plain middle and plain fast. Let's go plain middle. Let's send it to the ESC. And then let's go ahead and cut power. It's weird, there's no exit, and I just really want there to be an exit in this whole system, because then I have some level of confirmation that it's done. Well, the thing is, you get confirmation on each step on this YEP. Electronic speed control. Unlike usually, you'll just get kind of a acknowledgement that everything is done because you write it all at once. Okay, throttle cuts on, sticks down. Everything's turned on. Okay, everything's initiated, throttle cuts off, making sure nothing takes off. Throttle cuts on. Just moving the prop blades out just for extra security measure. Okay. Throttle up slow. Full throttle. Down. Good braking, nice smooth transaction there. And watching the full throttle, I'll show you this real quick now. Boy, that is super smooth, guys. Okay, so you can see that there's a distinct increase in speed. I actually like that better. I'm afraid that the slow timing is going to be way too slow, and we're going to end up crashing because we're going to be getting on the throttle and it's just not going to give us power quick enough. So let's watch our output here. Throttle cuts off. I'm going to jack the stick all the way up really quick. Ready? Go. Peaked out at about 22 amps. Peaked out at about a little over 20, almost 21 amps. So far so good, guys. I mean, it's looking really nice. I mean, we have ample power here. This thing is not hot. The thing that really interests me is that the S-Back is not hot at all. I don't know if it's just that the other companies are not telling the truth, which is totally possible, or if this is just a far superior S-Back, but typically the S-Back gets pretty hot. So also we don't have any servos hooked up, but I've been bench testing stuff in this manner before, and they still usually get pretty hot. So throttle cuts on. Everything looks good there. Real happy with the output, happy with the braking, happy with the ESC. So I'm probably, rather than dinking around with it, now this motor is, I would say, if anything, just above body temperature. So we'll call it 100 degrees. and real happy with it. So this bench test was a success. We're going to go with the 40 amp. I'm not even going to mess with the 30 amp. I'm happy enough with it. And in terms of weight differential, we're talking about right now the difference between 53 grams and 36 grams. It's significant, but we're not going to have to worry about running out of room. We're never going to top this out, and we're also going to manage the heat a lot better. So we don't have to worry about overdoing it and having a brownout as a result. Okay, so it looks like we're gaining about 17 grams. 17 grams is a lot of weight, guys. And it's tempting with that much weight to make a decision that would cause other problems. But I think for now, if we can fit it, we're going to use it. If we have problems with weight later, this will be our backup plan. We'll be able to save 16 grams. On a project like this, I don't think 16 grams is going to be a big deal. It's just that you can't always say yes to extra weight every single time, because you will make a heavy plane really quick. And I don't know if you guys remember, but earlier on in one of the earlier videos, we saved something like 100 grams on this and this, which are the rods that connect the wings. And we went to a carbon fiber configuration, which saved us just a load of weight. In fact, how much was it? It was like 90 grams of savings. But either way, so far that's where we are. Our next step is going to be to start getting some of the assembly actually done. But it's been a long time coming getting to this step, so I appreciate you guys sticking in there. It's been a lot more work than I thought to get the electronics figured out on this. But I'm happy with it so far. Oh, real quick, while we've got this still rolling, I'm going to take my marker, and just for easy remembering, you can either do heat shrink, but I don't want to add weight, so I'm going to take and mark the letters of the motor right there. And since this is yellow, which was part of the plan, I can then mark this, and that will tell me which wire goes which. And we'll just do another one with blue. Blue might be a little bit tricky to see, but we're going to do it anyway. Obviously we don't need this plugged in, so we'll just take and lift up our little guard there. Coloring in the white portion allows us to make a blue mark, but it doesn't show up real great. So I think on this one, depending on if the green shows up better, we'll at least have a way of differentiating. Normally you would just leave one unmarked, but in this case I just want to make sure I have less ambiguity here. So yeah, that green shows up a little bit better, so we'll do green there. Alright guys, you get the idea. We're getting really close. Also, my 5mm collet, which is the thing that bites the shaft of the motor, is supposed to be here pretty soon, so we'll hopefully have that ready to install, which will take care of this potential oscillation issue. I might fight that a little bit longer right now, but I'm not going to bore you with the video because it's going to be very boring. Thanks a lot guys for watching. Don't forget to like and subscribe. Click the bell for notifications if you want to follow along this project.